The weapon resembled industrial tubing, not a pistol. A smooth cylinder sat where slides usually moved. The magazine hung below, pretending to be a grip. There was no frame profile, no obvious handgun silhouette. Designers at Station 9 configured it for anonymity. British paperwork called it simply a silenced pistol. Later descriptions attached another label, Assassin's Pistol. Its official drawing showed a bolt, not a slide. The well rod operated with a manually cycled bolt. Each shot required deliberate rotation and retraction. The next cartridge rose under spring pressure. The bolt face stripped it, chambered it, and locked. The system offered no automatic repetition of fire. This absence was the point, not an omission. SOE planners prioritized silence over immediate follow-up shots. And earlier suppressed pistols still cycled themselves noisily. Slides slammed against frames after every discharge. Recoil springs compressed, then rebounded audibly. Spent cases ejected with metallic impacts nearby. All these events created distinct mechanical signatures. Reports from occupied territories described such signatures compromising raids. Engineers at Station 9 documented that disadvantage carefully. The well rod removed nearly all moving noise, nothing reciprocated under recoil after firing. Only the firing pin moved at the shot. The cartridge case stayed captured in the chamber. Gas flowed forward into the suppressor stack. The operator decided when to unlock and extract. He could wait while echoes dissipated indoors. He could time the action with ambient noise. The mechanism gave control, not speed, to handlers. The well rod's tube housed several functional zones. The rear section enclosed the bolt and striker. The central section contained a heavily ported barrel. The forward section contained baffles and rubber wipes. All were aligned along one axis, without protrusions. This layout simplified machining and inspection operations. Cylindrical parts lent themselves to lathe-based production. Tolerances along the central bore carried priority. Concentricity influenced both accuracy and suppressor efficiency. The magazine functioned simultaneously as a detachable grip. With the magazine removed, the weapon resembled equipment. Some reports noted resemblance to a bicycle pump. That visual ambiguity informed design from the outset. A separate grip frame would advertise pistol identity. Engineers deleted it and accepted handling compromises. So the compromise gained concealability and sanitized transport options. Agents could carry the cylinder and magazine separately. Inspection by cursory searchers might not connect the components. British records attribute the design to Major Reeves. He worked through the Inter-Services Research Bureau. Station 9 at Welwyn coordinated much clandestine equipment. The well prefix came from that location. Rod followed criminal slang for a handgun. The combined name hid function behind internal shorthand. Manufacture involved at least Birmingham Small Arms Company. Other contracted makers remained deliberately anonymous in files. Weapons left factories without standard proof marks. They carried only serial numbers and obscure symbols. Ordnance officers added any necessary ownership markings later. So this separation complicated peacetime attribution decades afterwards. Most well rods were chambered for the .32 ACP cartridges. Smaller cartridges produced lower muzzle blast pressures. Subsonic muzzle velocities avoided ballistic shock waves. A 9x19mm variant existed for separate requirements. Porting bled gas to keep those bullets subsonic. In both calibers, the goal stayed identical. Mechanical function served the suppressor, not conversely. Within the suppressor, several small ports perforated barrel walls. These allowed high-pressure gas into the first chamber. Pressure dropped before gas reached the forward baffles. Metal baffles redirected flow through narrow apertures. Rubber wipes then constricted the bullet path further. Each wipe opened temporarily and then closed again. The sequence stretched gas release over extended milliseconds. Short, sharp reports became dull, low-energy sounds. Field witnesses compared it to a muffled cough. A concave muzzle face supported contact shots cleanly. The curve improved stability against fabric or skin. The design reduced sideways skidding during close application. Contact use also sealed more gas inside. This further minimized escaping noise into the surrounding air. Technical notes described contact firing as most effective. The sights remained rudimentary but functional for daylight. They consisted of fixed irons along the tube. Dots received simple luminous paint for low light. Practical instructions emphasized short-range engagement distances. Documentation mentioned effective ranges measured in yards only. Contact or near contact use dominated tactical guidance. The bolt handle appeared as a knurled rear knob. Rotating it unlocked lugs from the receiver wall. Rearward travel completed extraction and ejection together. A fixed ejector blade struck the cartridge rim, tilting the weapon slightly controlled where brass fell. Operators received training to deflect cases discreetly. Cases could be caught in the support hand. Some accounts suggest pockets were used as improvised catchers. The trigger group sat in a narrow housing beneath. Linkages transferred motion up into the firing mechanism. The safety lever occupied a position near the trigger. Settings typically allowed safe fire and sometimes lock. Safe prevented striker release but left bolt movable. Additional locking stops restrained both bolt and trigger. These options existed to avoid unintentional noise during handling. The magazines differed slightly between the two main calibers. The .32 version usually carried 8 cartridges. The 9mm version generally offered 6 rounds. Both patterns used single-column arrangements for reliability. Feed lips were comparatively long to control presentation. The outer casing formed the operator's grip surface. Stippling or simple grooves improved contact with gloved hands. Tooling for the tube began with center lathe operations. Bar stock was bored, faced and threaded in sequence. Porting required accurate indexing along the barrel axis. Drill fixtures prevented bit wandering through thin barrel walls. Workers checked port diameters with plug gauges regularly. Oversized ports risked pressure imbalance and baffle erosion. Undersized ports limited gas diversion and reduced suppression. Scrap barrels accumulated where drilling exceeded tolerances. Inspection sheets recorded these rejects as a routine manufacturing waste. Baffles were turned from mild steel or similar alloys. Each piece received a central aperture and side vents. Stacks were assembled in specific order for tuning. Orientation affected flow paths and back pressure levels. Assemblers followed diagrams stamped with simple arrows. Incorrect orientation could produce baffle strikes on bullets. Test firing after assembly confirmed clearance and concentric alignment. Errant units returned immediately to the fitting benches. Rubber wipes wore out after relatively few firings. Repeated bullets punched permanent openings through material. Sound reduction degraded as these holes enlarged over time. Operational instructions therefore treated the well rod as consumable. As said, it was not configured for prolonged firefights or campaigns. Silent performance took precedence over long-term durability. Agents received compact maintenance kits with selected weapons. Kits contained cleaning brushes sized to the bore. Oiled cloths addressed corrosion from residue and humidity. Simple disassembly tools allowed removal of front suppressor sections. Rubber wipes could then be replaced under controlled conditions. Field documents implied armourers handled most wipe changes. Users were discouraged from unsupervised suppressor disassembly on missions. Testing at British facilities compared well rod noise levels. Standard pistols produced recognizable gunshot signatures outdoors. Ordinary suppressed pistols reduced these signatures but remained identifiable. Well rod reports were described as very low intensity, and some museum notes likened them to a finger snap. Witness statements varied depending on surroundings and expectations. Concrete passages amplified even minor gas leaks audibly. Soft ground and foliage damped reflections and echoes further. The bolt action decision extended beyond simple quietude. A locked bolt contained gas better than blowback systems. Backwards case movement contributed significantly to sound emission. By removing powered extraction, designers capped that contribution. The chamber remained sealed until deliberate manual unlocking. Gas pressures decayed substantially before that point occurred. Extraction, under low residual pressure, produced minimal additional sound. Rate of fire calculations became secondary in evaluations. Typical engagement scenarios involved single-target neutralization only. Mission reports rarely mentioned extended exchanges using well rods. For that function, other weapons were allocated separately. In procurement terms, well rod filled a narrow capability gap. Its specification sheet emphasized discretion, not volume of fire. SOE and OSS distribution used dedicated channels and cover. Serial numbers were recorded in separate ledgers from standard arms. These ledgers often used vague descriptions of equipment categories. Codes replaced explicit references to assassinations or clandestine tasks. Consignment crates bore ordinary packing descriptions and routing paperwork. Customs officials encountered agricultural or engineering labels instead. Inside, weapons lay wrapped in oiled cloth and paper. Issue procedures required signature on temporary charge documents. An agent seldom retained weapons on permanent personal inventory. Recovery, when possible, returned items to shadow armories. Damage reports triggered maintenance inspections and replacement authorizations. Destroyed or abandoned examples generated brief loss statements. These statements simplified to phrases like unrecoverable after action. The well rod also appeared in later conflicts sporadically. Special forces valued its unchanged performance profile. By then, more sophisticated suppressors existed in inventories, yet few alternatives matched its combined quietness and compactness. This persistence suggests the original engineering choices remained valid. On the workshop floor, well rod parts moved in batches. Fixtures held multiple tubes for simultaneous machining passes. Coolant flowed over steel, carrying swarf into trays. Operators monitored cutterware with small magnifying lenses. Chatter marks created local weaknesses and disturbed gas flow. Pieces showing such marks went to rework benches. Workers used fine files and abrasive cloth to smooth. Reworked parts received second inspections before final acceptance stamping. Acceptance stamps themselves stayed deliberately generic. Typical crown and proof symbols were omitted entirely. Small letters or numerals indicated internal batch tracking. These codes referenced separate confidential manufacturing records. If captured, the weapon revealed minimal origin information. The absence of markings was therefore designed, not accidental. The grip magazine interface required careful tolerance management. Too loose and the grip felt unstable during firing. Too tight and field stripping became slow and noisy. Production shops measured latch engagement with depth gauges. Any binding produced noticeable scratching on parkerized surfaces. Such evidence led inspectors to mark pieces for adjustment. Surface finishes tended toward dull, non-reflective treatments. Shiny edges risked catching light in confined spaces. Parkerizing or similar finishes improved corrosion resistance significantly. Oil absorbed into these surfaces aided rust prevention. Grease application remained minimal around the suppressor internals. Excess lubricant could migrate into rubber wipes over time. That migration caused swelling, hardening, or accelerated breakdown. Maintenance instructions warned against indiscriminate oiling of the baffle stack. Training documents for agents covered basic manual of arms. They described loading, cycling, and safe carry positions. As students practiced cycling the bolts slowly without cartridges. Instructors listened for metallic clicks or scraping sounds. Any noise above a low threshold prompted further coaching. Users learned to cushion bolt rotation with thumb pressure. They also learned to halt mid-stroke if interrupted. Live fire training emphasized very short distances on targets. Shots were fired into sand-filled backstops or earth. Observers stood nearby to gauge acoustic signatures realistically. Report levels were tested against background noises present. Agents came to understand where the pistol blended best. Urban settings with machinery masked it efficiently. Quiet rural environments exposed residual sound more clearly. Jammed or misfed rounds created particular procedural concerns. Clearing drills avoided vigorous racking that produced unnecessary noise. Operators first attempted gentle forward pressure on the bolt. If that failed, they withdrew slightly and reseated. Only after several controlled attempts did they unload completely. Ejected live rounds were collected rather than left visible. Such details appeared in memoranda on tradecraft and security. Bureaucratic correspondence occasionally questioned well rod production priorities. Some officers preferred more broadly useful suppressed carbines. Others advocated for increased numbers of conventional submachine guns. Supporters of the well rods cited specific operational successes. They pointed to missions where silence outweighed sustained fire. These arguments appeared in procurement notes and committee minutes. Quantities ordered ultimately reflected compromise between competing demands. The well rod shared design philosophy with the Delisle carbine. Both weapon systems used bolt actions by intention. Both combined pistol cartridges with integral suppressors for discretion. Both accepted reduced rate of fire as necessary. Engineering teams saw suppression as the primary design variable. Everything else, including ergonomics, followed after that requirement. Magazines required their own inspection sequences before mating. Feed lips were checked against hardened steel gauges. Springs were compressed fully to test for binding. Floor plates were tapped to confirm secure engagement tabs. Then magazines were inserted and removed multiple times. Any rattling prompted slight reshaping in dedicated vice fixtures. Transport logistics separated components whenever practical. Cylinders travelled in crates labelled engineering equipment. Magazines and grip pieces moved in separate consignments. End-user assembly occurred only shortly before operational deployment. Documentation for each component used neutral technical descriptors. Nowhere did labels combine to explicitly identify a pistol. The well rod's ergonomics remained austere and functional. The tube offered limited purchase for the support hand. Operators sometimes wrapped fabric or tape around forward sections. This practice improved grip but risked trapping moisture. Armourers removed such modifications during routine inspections afterwards. Official spare parts catalogues did not include auxiliary foregrips. Repeated firing heated the suppressor body noticeably. Metal temperature rose as gas bled into chambers. Heat gradually softened and degraded internal rubber wipes. For that reason, firing schedules avoided long strings. Operational doctrine kept round counts low per engagement. Technical tests recorded wipe performance falling after limited use. The bolt's simplicity also aided cleaning after missions. Carbon accumulated mainly in the chamber and first baffles. Users pushed cloth patches through with supplied rods. Stubborn fouling required solvent issued in small bottles. Chemicals were selected to spare rubber components where possible. Instructions specified drying times before reassembly and storage. Comparative trials set well rod signatures beside other systems. Observers sometimes stood with backs turned to firing points. They recorded which shots they identified or missed. Yet in such controlled conditions, well rod shots often went unnoticed. Other weapons with reciprocating parts were consistently detected. These notes reinforced confidence in the manual action choice. From an engineering perspective, the bolt eliminated timing constraints. Semi-automatic weapons required balance between pressure and cycling forces. Extreme suppression tended to disturb that balance unfavourably. By decoupling cycling from recoil, well rod accepted aggressive gas venting. Porting could be generous without starving operating mechanisms. That freedom translated into quieter overall performance envelopes. Controllability during firing benefited from the pistol's weight distribution. Mass concentrated along the bore rather than above grips. Recoil impulse drove straight backward through the shooter's hand. That muzzle rise stayed limited even in the 9mm variant. This helped place rapid second shots when conditions allowed. Any delay came from manual cycling, not recoil management. The pistol's unusual profile also affected holster arrangements. Conventional handgun holsters were unsuitable for the tube. Some carriers used ad hoc sheaths made from leather. Others relied on simple canvas sleeves within baggage compartments. Protective padding focused on keeping sights from being bent. There was little else projecting to catch on fabric. Inventory forms had to accommodate the weapon's dual nature. It could be listed under pistols or special stores. Different clerks interpreted classification guidelines in varying ways. Later researchers therefore encounter inconsistent archival indexing entries. The underlying hardware remained identical despite such administrative variation. Safety considerations included potential gas escape at joints. Threaded suppressor sections needed secure engagement under pressure. Torque specifications were included in assembly instructions. Too little torque risked loosening during repeated firing. Too much risked galling threads or distorting baffle alignment. Wrenches with limited handles encouraged moderate force application. For clandestine armouries, storage procedures mirrored other controlled items. Well rods were kept in locked cabinets or chests. Separate compartments contained ammunition and magazines for accountability. Logs recorded withdrawals with times, names, and planned use. Returns required notes on shots fired and any malfunctions. Such records rarely mention dramatic narratives, just figures. Some post-war documents describe examples retained for training only. New generations of personnel learned from obsolete hardware. They experimented with its quiet report in modern conditions. They also studied how simple tools achieved precise effects. The well rod became both artifact and teaching aid. Its influence extended into later veterinary pistols and derivatives. The B&T VP9 followed similar mechanical principles closely. It used a bolt-action and integral suppressor combination. It targeted humane animal dispatch rather than covert warfare. This civilian application confirmed the robustness of the concept. Across its life, the well rod remained technically consistent. It never acquired automatic variants or extended magazines. It never gained optical sights or accessory rails. As changes focused instead on calibers and minor manufacturing refinements. The central trade-off between quietness and rate stayed untouched. Designers accepted slower firing to achieve mechanical silence. They accepted awkward grips to disguise functional purpose. They accepted short effective range to optimize subsonic behavior. They accepted consumable suppressor components to minimize residual sound. Each compromise aligned with a narrow operational profile carefully. Viewed through this lens, the bolt was not a mistake. It was the enabling feature that made the system credible. From drawings and surviving examples, one conclusion emerges plainly. Every unusual feature exists to serve suppressed performance objectives. Manual operation, ported barrel, integral suppressor, and magazine grip. Together, they formed a coherent response to clandestine requirements. The Welrod embodied engineering ruthlessness toward a single specification. It traded speed for control, noise for concealment, complexity for reliability.